Hey Rose, this is part 3 of the course review, where we're going to focus on trig ratios, trig functions, and binomial powers. So the first question, we're on question number 12, says that the point P negative 2, 3 lies along the terminal arm of the angle theta in standard position. We're asked to find the exact value of the sine of theta, but in future courses, if you're asked to find the sine of theta and you're not told the level of precision, you should assume that they're looking for an exact value. Sketches will continue to be useful in advanced functions. Here's negative 2 comma 3 right here. So I've got an x value of negative 2, y value of negative 3. The sine of theta, its definition, is the ratio of y to r. So I think I just need to find an expression for r. R is going to be the square root of the sum of the squares of these components, and that's going to be the square root of 4 plus 9, or root 13. So the sine of theta is going to be 3 root 13ths. You could rationalize that to 3 root 13 13ths, but I don't think that's any simpler. And usually when a student jumps to that, I get the feeling that they've just tried to use a calculator to get an exact value. The other prompt you can sometimes use is often in my 3U and 4U courses. If I want students to use their calculator, I will use the word calculate. I'll use the verb calculate. And if I use the verb determine or find, then it usually means that they don't need a calculator. Hey, here's an example of that. In question B, we're asked to calculate the measure of the angle to the nearest degree. Let's use our sketch first to convince ourselves that theta is in the second quadrant. It's between 90 degrees and 180 degrees. In advanced functions, you'll be referring to this more of it's between a quarter rotation and a half rotation. So I will have to use my calculator here. Say that the sine of theta is 3 root 13ths, and I'll use my calculator to figure out what is one solution here. And we actually now can use our curves as well to answer this, to find the other answer, to see that there are two solutions between 0 and 360 degrees. Is that provided here? Yeah, I guess we would need to specify that theta is a principal angle. But yeah, the calculator is not going to give me that answer. I can predict my calculator is going to give me this answer in the first quadrant, where the ratio of y to r would be 3 to root 13. So I'm not going to be fooled by my calculator, and I'm ready to have to perform other calculations. This angle beta is about 56 degrees. That means the angle that I'm looking for, theta, is the second quadrant angle that has a related acute angle of 56 degrees, about 124 degrees. Okay. Question 3. It's been a while since we've actually done a formal left side, right side trig identity. Multiple choice questions kind of need to be done in a bit of a different way. I will start by separating the identity and making no changes on this step. Okay. The right hand side, I see the cosecant of theta multiplied by the secant of theta. And I have a feeling that if I work on the left-hand side, I can manipulate this to get it into primary ratios, and then maybe just my goal is to find a reciprocal of the sine of theta and the reciprocal of cosine of theta. Tangent ratio, quotient identity, sorry, is the sine of theta divided by the cosine of theta. The reciprocal of the tangent ratio then is going to be the reciprocal of that, cosine of theta divided by the sine of theta. My right-hand side, I don't see any sums, so let's write this with a common denominator. Let's do the sine of theta multiplied by sine of theta over the sine of theta. Here I'll multiply by the cosine of theta over the cosine of theta. That'll give me the sine of theta squared plus the cosine of theta squared, all over the sine of theta multiplied by the cosine of theta. Here's the Pythagorean identity. That's 1. Let's not do too much on one step. So we are not trying to get the left side to look like the right side. We're trying to show how it can happen. And then the reciprocal of the sine of theta is the cosecant of theta. And the reciprocal of the cosine of theta is the secant of theta. So there is my left side being equal to my right side. Okay. You end up using identities more in advanced functions and calculus instead of just proving them. Question 14, a 3D trig problem. An owl at an elevation of 10 meters sees a mouse to the south at an angle of depression of 10 degrees. I guess I'll start drawing. Owl's at an elevation of 10 meters. I guess this is going to have to be south here. At an angle of depression of 10 degrees. I'll use parallel line theorem. 10 right there. This is the owl. This is maybe the ground. And it sees a mouse right there. Okay. It sees a vole to the northeast. Yeah, I think that's supposed to be directly northeast, like north 45 degrees east or east 45 degrees north. At an angle of depression of 25. So that's in a different plane. Here's the ground. Here's the owl, 10 meters up. Here's the vole. Vole's like a mouse. Angle of depression of 25. These diagrams are actually a little bit reversed. The angle of depression of 25 degrees is larger, and that means that the vole is actually closer to the owl than the mouse is. But I'm not going to worry too much about that. Okay, how far apart are the mouse and the vole to the nearest tenth? Reference labeled diagrams. So this is a side view 1. This is a side view 2. Here comes a top view. From the top view, the owl will be floating above, but I will put the ground right here. The mouse is to the south of the ground and of the owl, and the vole is to the northeast, north 45 degrees east. Would have made that a little bit clearer, I think. There's 90 degrees. We're trying to figure out how far apart are the mouse and the vole. I'll call that distance D. Here's my plan. I have two right-angled triangles that I don't need to use sine laws or cosine laws for. Both of those have shared sides. Let's call this the distance for the mouse and the distance for the vole. I can find the distance for the mouse and the distance for the vole. Transfer side length MG to MG here. Transfer side length GAV to GV there, and then use the cosine law, since I know that this angle right here is 45 degrees plus 90 degrees, which is 135 degrees. And I'm ready to go. I'm asked to reference label diagrams. I'm going to try to do my work directly below these diagrams, which should help my reader figure out where I'm working, but I'm also going to tell them that I am working in triangle MGO. I will say, let's see, I can use a tangent ratio. That the tangent of 10 degrees is going to be 10 divided by m. I guess I could have done the tangent of 80 degrees as m divided by 10 instead. You'll learn in advanced functions that the tangent of 10 degrees is related to the tangent of the complement of 10 degrees. It's actually the cotangent of 80 degrees. So this will be 10 divided by the tangent of 10 degrees. This kind of reminds me a little bit of the Romeo and Juliet problem, except it's easier. In the Romeo and Juliet problem, we could have kept that expression exact. There's no advantage here. Unless you don't have a calculator. I'll just round this off and be careful about how much I round it off by. Call it 56.71. I like having that value because I can judge the reasonableness of it if I had drawn my diagram better. See if I can squeeze this in here. In triangle VGO, the tangent of 25 degrees is going to equal 10 meters divided by V. So it's really just the same operation again. 10 divided by the tangent of 25 degrees. The tangent of 25 degrees is larger than the tangent of 10 degrees. So when I divide by a larger number, this output's going to get smaller. Which goes back to what I said about the problem in my sketch, is that the vole actually should be closer than the mouse. Okay. Put that information on this diagram here. This is 56.71 and this is 21.45. I'm not going to squeeze in a cosine law down there. That's why it is useful to tell your reader in what triangle you are working. In triangle MGV, I'm going to say that d squared is going to equal 56.71 squared plus 21.45 squared. This is an approximation. Minus 2 times 56.71 times 21.45 multiplied by the cosine of 135 degrees. And it's calculator work from here. 56.71 squared plus 21.45 squared minus 2 times 56.71 times 21.45 times the cosine of 135, and make sure you take the square root of that because they're not 5,000 kilometers apart or meters apart. They're about 73.5. This is pretty much Emma on a bridge or Philip in a hot air balloon. Same kind of question we've answered in the past. They are about 73.5 meters apart. Good. In vectors, you learn other ways. The vectors portion of the calculus in vectors, you learn other ways of dealing with three-dimensional problems. Question 15, we have 3 trig equations. We're asked to solve for all principal angles to the nearest degree. I really like this question for review. And I feel like this is where I should start using my curves. Although, you know what, we didn't really talk about the tangent curve, so I think I'll have to use ratios for that one. Maybe I'll do a curve approach for one of these, maybe the last one. Okay. Solve for all principal angles to the nearest degree. So cosine of theta equals negative 1/3. Well, the cosine ratio is the ratio of x to r. Let's draw a sketch in standard position if you like. There's no phase shift, no change to the period. I should be able to use standard position. I'll draw a circle of radius 3 and the line x equals negative 1. That shows me where my two solutions are. There's theta 1, here's theta 2. I can tell then that my calculator is going to tell me one of these answers. It's going to tell me theta 1 first. If you want to use a curve approach, draw yourself a cosine curve with the amplitude of 1. Axis the curve of y equals 0. You draw the line y equals negative 1/3. There's theta 1. Here's theta 2. Notice the symmetry right here. That's going to be back theta 1 from that maximum. So in standard position, I see there's a solution in the second and third quadrant. In my curve, which should be labeled, I see that there's a solution between 90 degrees and 180 degrees, theta 1, and a solution between 270 degrees and 360 degrees. Sorry, 180 degrees and 270 degrees, theta 2. Okay. My calculator will tell me one of these solutions, and I'm ready for that fact from both of my diagrams. That's the answer closest to 0. That's the answer closest to 0. In degree mode, inverse cosine of negative 1/3 is about 109 degrees. A couple of different ways you can get theta 2. I think I usually found the related acute angle. This time I'm going to subtract 306. No, that's not quite going to do it. I'm going to take negative 109 degrees and add 360 degrees from it, or to it. Theta 2 is negative 109 degrees plus 360 degrees. From the curve, I think maybe you would see this better as being at 360 degrees, and then you go back 109 degrees. So that, sorry for the space here, 360 minus 109 is going to be about 251 degrees. The tangent curve, you learn how to sketch in advanced functions. Dealing with this in standard position, we do just need to be careful because we have a ratio of y to x. Over here, I knew that x was negative because r had to be positive. Here, either y or x could be negative, but not both. So you might want to treat it as two different ratios. And you might want to draw two different diagrams. Let me do my diagrams down here. In one, I have a y value of negative 1 when x is positive 3, 3, negative 1. Sorry, I don't actually know the x and y values. I know the ratios, don't I? Like that. There's, I'm going to call it theta 2 because I can tell it's going to be my second solution. Theta 1 would happen when I have a ratio of x to y of 1 to negative 3. So go left 3, up 1. Like that. There's theta 1. When I ask my calculator, it's going to tell me that answer right there. So I'm ready for an answer that I don't want because it's not a principal angle. The inverse tangent of negative 1/3 is about negative 18 degrees. Well, theta 2 is going to be 360 degrees minus 18 degrees. That's 18 degrees back from one full rotation, 342 degrees. Theta 1 is 18 degrees back from a half rotation, 180 degrees minus 18 degrees. What's that? 162 degrees. And there's my two solutions. Okay. Let's try this one just from the curve. Sine of theta equals negative 1/3. I'm going to draw a sine curve with an original period of 360 degrees, an original amplitude of 1, axis of the curve of y equals 0. When I draw in the height negative 1/3 right there, there's y equals the sine of theta. There's y equals negative 1/3. I can see my two solutions between 0 and 360 degrees within one full rotation. There's theta 1, there's theta 2. I can also see the answer that my calculator is going to give me. The calculator is going to tell me that answer because it's the closest one to 0. So I'll say beta is going to be the inverse sine of negative 1/3. Inverse sine of negative 1/3 is about negative 19 degrees. I'm going to treat theta 2 as a periodic solution. That should happen 360 degrees, sorry, one full period later, which in this case is 360 degrees. So theta 2 is negative 19 degrees plus 360 degrees. You could also see this symmetric distance. That's 19 degrees back from an axis point. This axis point happens at 360 degrees. You go left 19 degrees from there, and you will end up at 341 degrees. Theta 1, I think I'll use some symmetry approach. This was left 19 degrees from an axis point. Let's go right 19 degrees from an axis point. 180 degrees plus 19 degrees gives me about 199 degrees. Okay. Lots of understanding from the sketches there. Very little memorization. Maybe just the ratios need to be memorized. Question 16. I need to zoom in on a bit. I'm having a hard time reading that. We did a bit of this question in one of our quiz, but I don't think we tackled the full thing. You know what? I think I better draw the diagram. Question 16, we're asked to find an equation. There's an infinite number of them, but some equation for the given curve. The given curve is sinusoidal. Let me draw my frame so that it actually looks sinusoidal. Axis of the curve. Like that. And we're told that this point right here happens at 7 comma something. And then this point right here happens at something else, comma 55. I hope it's obvious that those have to be different. This axis point right here happens at 11.5 comma something. And this right here happens at something comma 21. I really like this question because it's not overloading you with information. You have to really pick the information that you're going to use. To get a curve, and I might actually just make the choice to use a vertically reflected cosine curve and use 7 as my phase shift. I am going to need to know my periodic properties. I need my amplitude, my axis of my curve, and my period. Let's start with the vertical values. Let's start with the amplitude. 2 amplitudes is going to be the difference between 55 minus 21. That means that one amplitude is going to be, what is that, 34 divided by 2 or 17. I did that more from an understanding. I don't think this is an approach I ever showed you. I saw a lot of students mixing up formulas for amplitude and axis of the curve, and I really don't want you using formulas. You should be able to see on here, your amplitude is half of your range. So calculate your range and then divide that by 2. My axis of my curve is going to happen at a height, that's actually q, isn't it? That's not really the axis of the curve anymore, is it? The q value given from the axis of the curve is going to happen 1 amplitude above this minimum or 1 amplitude below that maximum. I'm just going to do 1 amplitude above that minimum, the value of 38. So I've got my absolute value of A, I think I decided I want that to be negative in order to have a vertically reflected cosine model. I have my Q value. It has to be shifted up 38. The period. Let's see. I'm not told information to find a total period or a quarter period or a half period. I'm given information for 3/4 of the period. And this happened in our quiz. So just like right here, how I could say that that difference is going to be 2 amplitudes, I'm going to say that 3/4 of my new period is going to be the difference between 11.5 and 7. That means that 3/4 of my new period is going to be, is that 4.5? Normally I would multiply both sides by 4 first. In this case, I think I see it's a little bit easier to divide both sides by 3. Actually, let's do multiply by 4/3 instead. And then I can do 4.5 divided by 3 is 1.5 times 4 is 6. So my new period is 6. And some students are able to get that value but have a hard time communicating it. Now let's be real careful here though, because even though I have my new period, my period doesn't show up in my function. What shows up in my function is my k value. Let's go through this again. Your new period is a horizontal stretch of your old period. Your horizontal stretch factor is the reciprocal of the absolute value of k, and in this course, your new period was 360 degrees. We need a new period of 6, absolute value of k there, times 360 degrees. Let's multiply both sides by the absolute value of k, divide both sides by 6. And we get 60. Yeah. It's a lot easier than trying to figure out that you've had a horizontal stretch by 1/60th and then remembering to reciprocate that. So here comes our function. I don't think we have any function letters to use, so I'm just going to decide to use, I don't know, f of x. Is going to be, if I haven't made this decision yet, let's pretend I haven't decided if I want to reflect or not, but I need an amplitude of 17. I haven't decided if I want a sine or a cosine function yet. Most people decide not to reflect horizontally given the choice, but we need a k value of 60. It has to be in a factored form. I haven't decided on my shift yet horizontally, but vertically I have to have a shift of 38. So everyone's function has to look like that. 2 most popular answers, well, maybe 3 most popular answers. Non-vertically reflected cosine model shifted right 55. No, sorry, not 55. We don't know that value. 2 most popular answers. Vertically reflected sine model shifted right 11.5. Probably the most popular option would be a vertically reflected cosine model. If you want to see if your answer would have given you a correct answer, just type my answer and yours into Desmos and see if the 2 curves are coincident. Like that. I think that would be the simplest model to use. Okay. Question 17 is asking us to draw a sketch. So we're really going to be using these facts in reverse. I see a sinusoidal curve. I'm going to take one step from what's written on the page and write it in a factored form first. Let's remove a factor of 3, leaving me with theta plus 20 minus 4. I'm going to frame my curve, because I know this is sinusoidal, so it'll have an absolute maximum and an absolute minimum. Axis of the curve halfway in between, and I can start labeling some of this information. It was asked for 1 cycle? Yeah. The axis of the curve is going to be y equals -4. The maximum is going to be -4 plus 1 amplitude of 21. What's that, 17? The minimum height is going to be the axis of the curve height minus 1 amplitude. It's at -25. There we go. We are sketching a vertically reflected sine curve that has been shifted left 20 units or degrees. I'm not given any units on here, so I'm just going to label that -20. And a vertically reflected sine model, let's see, is going to fall to a minimum before climbing to a maximum. I'm going to try my best. This is maybe a little bit wider. Oh no, it's getting worse. To keep curving. Yeah, something terrible's gone wrong. Wasn't equally spaced. But you can tell, I hope you can tell that I'm trying. Okay, shouldn't ever be linear, shouldn't ever be vertical. I'd like it to be a little bit curvier there, but yeah, well, let's label that. What's left is our period. My new period is going to be 1/3 of my old period after a horizontal stretch by 1/3, 120 degrees, or units, let's say. I actually want my quarter period of 30. I think I'll find that more useful because now I can just add 30 to that, add 30 to that, add 30 to that, and add 30 to that. And then I can check and make sure that from negative 20 to 100 is actually a span of 120. So it should be pretty quick. You don't need, like, a mapping statement on 5 points isn't a good approach. Listing transformations also probably not necessary. Now, question 18 is from the unit on discrete functions that we didn't have a chance to look at. It doesn't come up much in advanced functions. When you talk about solutions to trig equations, your advanced functions teacher will show you how to write an infinite number of solutions. It's really just a linear equation. Those lessons and videos, the lessons are available on our website, and the videos are actually on my YouTube channel as well, because I thought that we'd be getting to them, and then someone changed their mind. But what we did get to is something that you will find useful in calculus if you choose to expand. I'll tell you, though, that usually, given the choice between expanding or factoring, you almost always want to factor instead of expand. But question 19 asks us to expand and simplify the first three terms of the 7th power of 2x cubed minus 3y. To do this, I'm going to need the first three terms of Pascal's triangle, not the entire triangle, just the first three terms. There's the first three terms of row 0, row 1, and row 2. Did I say the first 7 rows? Since I start at row 0, I actually need the first 8 rows. 1, 3, 3. It's a recursive definition. Interior elements are the sums of the previous elements on the previous row. 1, 4, 6, 1, 5, 10, 1, 6, 15, 1, 7, 21. These are going to be the original coefficients. It'll be 1 something something plus 7 something something plus 21 something something, like that. Just the first three. Okay. These things are going to be powers of 2x cubed, 2x cubed, and powers of negative 3y, negative 3y, and negative 3y. The exponent on the 2x cubed starts at 7 and decreases by 1 till you get to 0. 7, 6, 5 is an example of an arithmetic sequence. That's the unit that we skipped, where you're going down by 1. The exponents on the negative 3y, 0, 1, 2, also an arithmetic sequence going up by 1. Okay, that's how you use Pascal's triangle, and then the rest is just a little bit of algebra, because we were asked to simplify this. Let's see. Well, there's 1, 2 to the exponent 7. 2 to the exponent 6 is 64. So 2 to the exponent 7 is going to be 128. 7 groups of 3 groups of x is 21 groups of x. And this base to an exponent 0 is going to be 1. Then I'll have 2 to the exponent 6, 64. 6 groups of 3 groups is 18 groups. And I actually have 1 factor of negative 3y. Then I'll have plus 21. 2 to the exponent 5 is 32. 5 groups of 3 groups is 15 groups. And then I square negative 3y. The square of negative 3 is positive 9. The square of y is y squared. Like that. So there's still patterns in here. 128, 64, 32. That's called a geometric sequence. You're halving each time you go forward, kind of like in an exponential function. But the 7, 6, 5 was kind of like a linear function. All right, and then we multiply everything together that can be multiplied together. That gives us 128x to the exponent 21. I think I'll have minus here. Need a little bit of help from my calculator. 7 times 64 times 3 is going to be 1,344. I'll have x to the exponent 18, y to the exponent 1. And then 21 multiplied by 32 multiplied by 9 will give me positive 6,048. I'll have x to the exponent 15 y squared. I wrote plus dot dot dot. It's actually going to be minus dot 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 because it is an alternating sequence as well, too. Okay, biggest mistake to make here is to think that you can just raise this to the exponent 7 minus that to the exponent 7. That didn't even work when this was an exponent of 0 or 2. So do not distribute exponents. All right. Let me know if you have any other questions, and this material will be left up for a long time if you want to access it maybe at the start of your course in advanced functions, or if you're having a hard time accessing it and you have any questions, feel free to send me a message. Hopefully, I will be able to see you in the Math Help Center sometime in the near future if you have any other concerns. Good luck.